Welcome to the Algebra 2 video for skill number 87. I can graph and transform functions and identify transformations from graphs and equations. Throughout the year we've visited transformations and we have 6 basic transformations. Our first is a horizontal translation, and when we do that we replace x with x minus h. And if h is greater than 0, we're moving to the right. So, for example, x minus 3 squared would be a quadratic function that is moved to the right 3 units, as opposed to x plus 5, which is an absolute value function that is moved to the left 5 units. A vertical translation, we add k to the end of the function. So a vertical translation that moves up would be x squared plus 6 would be 6 units up, or we could say the absolute value of x minus 3 would be 3 units down. Reflection across the y-axis, we replace x with negative x. So if we had an equation that was x plus 7 and it became negative x plus 7, we've reflected that across the y-axis. And if we want to reflect across the x-axis, we put a negative in front of the equation. So if we had x squared plus 3, we would take that and switch it to negative parentheses x squared plus 3. Finally, a horizontal stretch and a vertical stretch. Horizontal, we replace x with x over b, or we may be more familiar with 1 over b times x. So if we took the equation, the square root of 1/3 x, we would know that was a horizontal stretch by a factor of 3. And the final one is a vertical stretch. And for that, we stick a number in front of the function. So if our function was the absolute value of x plus 5, and we stuck the number 2 in front of the whole function, that's going to vertically stretch it by a factor of 2. For this skill, we need to be able to do 3 things. First, we should be able to describe transformations, which we're pretty practiced in. Next, we should be able to find the x and y intercepts of a function before and after transformations. And finally, we should be able to graph a function from a transformation rule. Alright, so let's look at the first task is to be able to describe transformations on f of x. Now you notice here, f of x, that rule f is not told. It could be a square root function, it could be an absolute value function, it could be anything, but we still can look at what's going on to that rule to determine the transformations. So the 3 tells us a vertical stretch by 3. The x minus 4, which took the place of x, tells us to shift right 4 units, and plus 5 tells us to shift 5 units up. In the second equation, we have the negative in front, and the negative is telling us to flip the function over the x-axis. Then we have an x being replaced with 2x. What that means is horizontally compress it by 1/2, and then we have the plus 1 at the end, which tells us to move up 1. Example 2 is how to find the x and y intercepts of f of x without graphing, and we use this to find the x and y intercepts of g of x without graphing. So you might recall that to find x-intercepts, we set the equation equal to 0. And then to find the y-intercepts, we evaluate the function at f of 0, or at 0. So if we have the rule f of x equals 3x plus 6, our intercept we find by setting 3x plus 6 equal to 0. And we find an x-intercept of -2, 0. To find the y-intercept of rule f, we substitute 0 in for x, and we get 3 times 0 plus 6. So the y-intercept occurs at 6, or more specifically 0, comma 6. If we wanted to find the x-intercepts of g of x, which is a transformation of f of x, we have to think about what transformations happened. So we reflected it over the x-axis, which is not going to change the x-intercept. And we are vertically stretching it by 2. That will also not change the x-intercept. So for g of x, our x-intercept remains the same. However, our y-intercept, because we stretched it and flipped it, our 0, comma 6 gets stretched to 0, comma 12, and then we flip it, so our y-intercept happens at 0, comma negative 12. This skill here is perhaps the hardest part of this section and is best understood by doing several examples, so it's pretty extensively done in the homework. And the final piece of this skill, we are given f of x and we have to graph g of x. And what we see here is g of x is a horizontal stretch by 2 and a shift up of 2 units. So if our original f of x was graphed like this, you can see it with the dotted line, we're going to shift it up 2 units, and then we're going to stretch it out by a factor of 2 because we have a horizontal stretch by 2. So instead of going out 1, up 1, out 1, up 3, we're now going to go out 2, up 1, out 2, up 3, out 2, up 5. This might be more evident in the second example. The second example, we reflect over the x-axis. That's what this negative sign says. We're going to vertically stretch it by 3, and we're going to move it up 1. So if our original function is the red line, first we reflect it, and we get something like this. And then we're going to vertically stretch it, so we're going to get something like that, and then we move it up 1, and we get what is drawn here. So I'll erase those lines so we can see the graph better. All right, the key ideas and concepts for this skill. We're focusing on transformations. So if I give you a rule for f of x, and then I tell you that g of x is equal to negative 2 times f of x minus 3 all plus 5, you should be able to tell me the transformations that have happened. And this looks like we've shifted right 3, we have shifted up 5, we've vertically stretched by a factor of 2, and we've reflected over the x-axis. We should also be able to find the x-intercepts and the y-intercepts. So if I told you f of x was equal to x plus 1, we should be able to find the x and y-intercept of both f of x and g of x. And then finally, we should be able to, if we're given f of x, and in this case, f of x looks something like that, and then we transformed it, what does the new graph look like? And as I said, we reflected it over the x-axis, so there's that. Then we vertically stretched it by a factor of 2, so it looks something like that. Then we moved it to the right 3 units, so it's going to look like that, and then we moved it up 5 units. So our final answer looks something like that, very roughly. Okay, this concludes the lesson. Thank you.